Breast cancer is a disease where abnormal cells in the breast grow uncontrollably, often forming a tumor that can spread to other parts of the body. The average risk of a woman in the United States developing breast cancer sometime in her life is about 13%, meaning there is a 1 in 8 chance she will develop the disease. Comparatively, according to the American Cancer Society, less than 1% of all breast cancer occurs in men. There are over 100 genes that affect the inheritance of breast cancer, but the most notable involve mutations in BRCA1 and BRCA2, with other significant genes including TP53, PALB2, CHEK2, and PTEN. About 5 to 10% of breast cancer cases are due to genetic factors, while the remaining 90 to 95% of cases are attributed mainly to environmental and lifestyle factors, including age, diet, physical activity, hormonal factors, and exposure to radiation or carcinogens. BRCA1 and BRCA2 mutations disrupt normal DNA repair functions, especially in double-strand break repair, leading to genomic instability. Women with BRCA1 mutations have a 55 to 65% lifetime risk of breast cancer, while those with BRCA2 mutations face a 45 to 47% risk. The BRCA1 gene encodes a protein involved in repairing damaged DNA, which is crucial for maintaining genomic stability. This gene is particularly active in breast and ovarian tissues, where it helps suppress tumor formation by repairing DNA damage that could otherwise lead to cancerous growth.
Genetic tests can be helpful for those who choose to take them. Companies like 23andMe offer tests that provide personalized information about your health, potential risk, and other traits. Knowing this information can help you take a more proactive approach to your health and may allow you to live a life that isn't solely defined by your genetic makeup. Only a limited amount of information about an inherited condition can be obtained through genetic testing. The test frequently fails to predict whether a person will exhibit symptoms of a disorder, the severity of those symptoms, or whether the disorder will worsen over time. The accuracy of genetic testing is another limitation. When studying the accuracy of direct-to-consumer tests like those provided by 23andMe, researchers at Ambry Genetics found that 40% of variants in a variety of genes reported as false positives. Another limitation of genetic testing is the lack of current data that these testing companies have access to. For example, 23andMe only tests for certain gene variants, and many other disease-causing variants are not included in the test. This can lead to false reassurance, as you may not be tested for some of the most dangerous variants. One such variant is the RS386833395 SNP, which can increase the risk of breast cancer, particularly in certain ethnic groups, such as the Ashkenazi Jewish people. This mutation is rare, but if present, it can increase breast cancer risk by 40 to 50%. Since 23andMe does not test for this mutation, relying solely on their results could miss a significant health risk. Genetic tests can also create unnecessary stress. For example, 23andMe only tests for 44 out of more than 100 known variants in the BRCA1 and BRCA2 genes, which are linked to breast cancer. Some of these variants, like RS179995 on the BRCA1 gene, have a very small impact on cancer risk, only increasing it by 0.5 to 1.5%. Yet, if someone finds this in the results, they might worry unnecessarily about a small risk. Most women have a 1 in 8 or 13% chance of developing breast cancer without genetic influence, so the additional risk from some genetic variants is minimal. Genetic testing can also prove to be fairly expensive. While many people enjoy taking the genetic test without needing a doctor's referral, the results often require confirmation from a healthcare professional. These tests are expensive, and many insurance policies and plans do not cover the cost. It is also important to note that many have reported feelings of anger, depression, anxiety, and even guilt after receiving their results.
There are hundreds of other SNPs not tested by 23andMe that could also affect the trait. One of those is this SNP. This SNP is a pathogenic mutation that tends to be prevalent in certain ethnic groups such as the Ashkenazi Jewish people. This is a fairly rare mutation, only being seen 30 times throughout 120,000 alleles. This is a mutation on chromosome 17 and can significantly increase the risk of breast cancer when the AG genotype is mutated. While this is a rare mutation, there is a 40 to 50% increase in the risk of developing breast cancer if you possess this variation. The reason this mutation of the BRCA1 gene causes breast and possibly ovarian cancer is because the gene is only expressed in breast tissue and the ovaries. The BRCA1 gene is typically a tumor suppressor and stops cells from dividing too rapidly. So when the gene is mutated by this variation, it produces an early stop codon, which prevents the gene from repairing DNA, and the cells begin to divide too rapidly, causing tumors to form, which can ultimately lead to the development of breast cancer.
In order to gather information and find ways to best conduct our genetic test, we used 4 main sources. First, the Breast Cancer Medline Plus genetics website provided us with knowledge about the background of breast cancer, such as how it is inherited, who it affects, and the proteins that are altered in the people with it. Next, we used the National Library of Medicine that allowed us to understand the genetic variations that are not tested by 23andMe. Then, the Frontiers of Oncology website helped us to